Hi everyone, I'm Luca Prete from Open Networking Lab. I'm taking care of deployment there, and today I'm here to demonstrate a global SDN deployment in action powered by ONOS. So the goal here is to create a global SDN network providing layer 2 and layer 3 connectivity without using any legacy equipment, so no legacy switches, no legacy routers, and at the same time give the possibility to the research network guys to provide new services inside their networks. On our side, the goal is to demonstrate that ONOS can work not only on Mininet, which is great, but also in real networks, and at the same time what we call learn and improve. So get the feedback from the production guys, translate it into requirements, and then use the requirements to produce the new releases of ONOS. So what do I mean when I say enabling network innovation? So these are the applications that we deployed in the last 2 years in our testbed. We started from SDN IP, which basically is an application that translates BGP routes into OpenFlow entries on the switches. We then moved to VPLS, that is an application that lets you create layer 2 broadcast overlay networks on demand. And then the real news of this year is SDX layer 2, made by Giant, and Castor, done by Arnet in Australia. So what happened is that finally, these guys, for the first time, are able to bring innovation on their own in their network. So they develop the new functionality needed, and they deploy it on their own without waiting anymore for vendors. So let's take a look at the timeline of our deployment. This is where what we did last year, a year ago. So we started from Internet 2 in US, quarter 1, quarter 2, 2015. We then moved to AM Light, the research network of South America. And then we deployed in Giant and GAR, which are the research network of Europe and Italy. So at the end of 2015, we then deployed in Australia on Arnet, and just in the same period, Creonet was announcing that they were going to deploy by 2017 the first production deployment network covering different use cases, from packet optical to routing to virtualization, all with ONOS. A month later, we deployed ONOS there in Korea with SDN IP. Finally, early this year, we deployed in NCTU in Taiwan, and we created a rich topology till arriving to what you see right now on the screen that represents the testbed as it is right now. Okay, time to see what we will see today in the demo. We'll see, first of all, the network during normal operations, so we will see different video streaming, and then we will see different network monitoring tools that the research network use to monitor their traffic in the network. Then we will cause a failure in this network, so we will make a link go down in the network, and we will see how ONOS can recover from that failure, and we will check again these monitoring tools. What this means in terms of in our deployment. So first of all, we deployed all around the world different video servers that are streaming through the best path, all the videos, to a web server in Miami. On the other side of the web server in Miami, we have another interface that connects us to the public internet. And so all the website of the videos is publicly accessible now. Then let's focus on the loop that we have between Taiwan, Korea, and Miami. Of course, between Taiwan and Miami, we have a primary path, and then we have a backup path. So what we will do during the demo will be to make the primary path fail, basically turning off an interface on the router in Taiwan, and we will see how ONOS redirect the traffic through the backup path. Okay, time to go to the demo. So let's take a look at what we have right here. So the map that I showed you before is represented here by this map, which is the map using in the production network of AM Light, actually the production network of South America. Particularly, this map shows us now the BGP session that AM Light is having with all the other partners around the globe. In this case, you see that all the links are green, which means that all the BGP sessions are up and everything is running. That's why you see here a ping run from AM Light in Miami to NCTU in Taiwan. The other thing I want to show you today is the real ONOS GUI used by ON.Lab in the production network. So in this case, for example, you can see that the switches deployed are broken switches, and 3 instances of ONOS have been deployed. Same thing for Australia. In this case, the production GUI shows us that we've deployed in Sydney, Melbourne, and Perth NoviFlow switches, and we have 1 instance of ONOS running. Last but not the least, we have this green matrix. This is called Personar. It's something pretty popular in research networks, and in this case, it's giving us the idea of the packet loss that we have in the network, which is almost 0 between all the peers. So let's see. Let's create now a failure. What I'm going to do is to shut down the interface of the router in Taiwan. So I'll make this link go down. 2 things will happen. Within 30 seconds, the interface, the production interface of ON.Lab will acknowledge that the BGP session is down, and the link will become from green to red. The other thing that you notice here is that the round trip time went from 210 milliseconds to 540 milliseconds. This is because, of course, the connection, instead of going directly from NCTU in Taiwan to ON.Lab in Miami, is going through Korea and then to Miami. Okay? So let's wait a few seconds, and we'll see the link that will become red. All right, let's try to summarize what we have seen so far. So we deployed ONOS, 5 ONOS cluster, over 60 OpenFlow switches, 12 institutions connected over 5 continents. We validated different applications so far, including SDN IP, SDX layer 2, layer 3, and Castor. Each one of us has lots of work to do still. We are moving the ONOS intent framework, which is a fundamental component of ONOS, to use the multi-table pipelines, meaning more performances and more scalability. Research network claim to be like Google or Facebook, but they still don't have the agility to be like those guys, so they have lots of work to do to improve. Finally, as from the deployment point of view, as an engineering feedback, I can say that as much as I went to legacy vendor and famous vendor in this testbed, as much as I had problems doing deployments, as much as I moved to new vendor that just do OpenFlow, as much as I had less problem and it was easy to deploy OpenFlow. So there's lots of work also to do on the hardware. So what will happen? For sure, from quarter 2 2016, we'll start to bring more research network inside the global deployment. We will introduce, as we partially already did, support for multi-table pipelines. We will support new application, like for example, VPLS, which was just validated in ON.Lab, and we will deploy also packet optical, that's supporting also optical devices. And finally, we will support, as we always did, we will always have focus for stability, performances, and scalability. Thank you for watching the video.